All right, so good evening, everyone. So this evening, we're going to look at fractions. But before we start, I just want to do some of the basics to make sure that we're okay with them. Right, so just some reminders. In terms of fractions, we know that we could have proper fractions. Proper fractions is where the numerator, which is your number on top, is smaller than the number below, which is called the denominator. Right, so we have proper fractions. Right, and I'm just going to use examples so that you have them. So let's say they gave us 8/10. Remember your number on top, that is known as your numerator. I'll be using the terms, so you just have to make sure that you know them. And then the number below, that is known as your denominator. Now, your numerator, once that is smaller, once it's smaller than the denominator, that's known as a proper fraction. However, if it is that the number on top is bigger, then it's not going to be, like think of a lollipop. Like if you have the lollipop, once it is that the lollipop is, the sweetie part is bigger than the stick, then it wouldn't be able to stand on its own. It could fall, it could tumble. So in a case like that, if the number on top is bigger than the bottom, we call that an improper fraction. And we normally change them into mixed numbers. Right, so an improper fraction is where the numerator is bigger than your denominator. So let's say they gave you 10/8. And it's where the numerator is bigger. Now, you must be able to change an improper fraction into a mixed number. Basically, a mixed number is going to have a whole number right? So it's going to have a whole number and then your fraction. Now we need to know how to change between improper fractions and mixed numbers, because when it comes to mathematics and fractions at the CSAT level, we are going to need that working. Right, so just to note, I'll change the color of this part here. Right, so improper fractions to mixed numbers. What we do is that's like changing 10/8 into a mixed number. So what we're going to do is we're going to divide. We're going to divide my denominator into my numerator. right? So you're going to divide the denominator into your numerator. That value gives your whole number. Then what we're going to do next is you're going to see how much is remaining, right? So like in this case, 8 could go into 10 ones, right? But there's a remainder. That remainder is going to form your numerator. Right, so it's going to form the remainder. The remainder is going to form the numerator over the same denominator. So in a case like this one, if I had to change ten over 8 into a mixed number, we're going to see how many times 8 could fit into 10. 8 could fit into 10 once. And you have a remainder 8, 9, 10 of 2. So the remainder is going to form your numerator, and it's going to be over the same denominator. Let's check another one. So let's say they gave us 11 over 3. So 3 could go into 11. You divide 3 into 11, that's going to be 3 times. And then you have a remainder of 2. Right? Because 3 3s are 9, and 9 plus 2, that's 11. So the remainder of 2 is going to go over the same denominator. All right, so I'm pausing here for now to make sure everyone is with me. All right, so we saw how to change improper fractions into mixed numbers. Now we're going to look at mixed numbers into improper fractions. So mixed numbers into improper fractions, what we have to do is we have to multiply your whole number by the denominator and then add the numerator. All right, so let's say they gave us 1/9. To change this to an improper fraction, it's going to be 1, the whole number, which is 1, times the denominator. So it'll be 1 times 9, which is 9. And then we add the numerator. 9 plus 5, that's 14. And we're going to put it over the same denominator. The denominator stays the same. If they gave us 2 4/5, you multiply your whole number by the denominator. So that's 2 times 5, which is 10. And then you add your numerator. 10 plus 4 is 14 over 5. So that's how we change our mixed numbers into improper fractions. Now, just for the recording, we're going to just recap addition, subtraction, multiplication, and division of fractions to make sure that we understand. All right, so let's say we had to add fractions. We know that you could only add or subtract fractions we can own, this should be adding. Right, so adding fractions, not add fractions. Right, so when we're adding or subtracting fractions, you could only add or subtract, remember, if your denominators are the same. So if I have two different denominators, I have to make them the same by finding the LCM. If you have trouble finding the LCM, remember LCM is the lowest common multiple. Right? So we're going to look at the multiples. When you hear multiples, you think of multiplying, and hence the timetable of each of these denominators. So it's going to have 3 and then the 4 times table. So you look at the 3 times table and the 4 times table. If you have trouble with finding the LCM, you could go through this method and you're going to look for the LCM. And in this case, the LCM is 12. So you ask yourself, what do I do? Because each of these, you have to make these 12. And in order to make them 12, you have to form equivalent fractions, right? You can't just change the denominator without working on the numerator as well. So we're going to multiply 3 times 4, whatever I do to the bottom to make it 12, I must do it to the top. I advise you that you know fractions with respect to this step because it's going to help when we come to algebra and fractions. Whatever I do to the bottom here to make this 12, which is multiplied by 3, I must do it to the top. And then we could solve. So 1 4 is 4 over 12 plus 3 1s are 3 over 12. And then the rule is once you're adding or subtracting fractions and your denominators are the same, your denominator stays the same, and then you either add or subtract depending on the operation between that. So that would be 7 over 12. Next up, we have multiplying fractions. Right, so we're going to look at multiplying fractions. Now, when it comes to multiplying fractions, let's say they gave you 3a times 2 quarters. Now, what I like to do, especially if you have trouble with fractions, is to encircle my numerators. What I want to do next is, it comes like you put the numerators into one house or one housing. The denominators, they are in a separate housing. So you want to look at from one house to the other house, and you want to see if you have any common factors that you could break down. So I look at my numerators. Do you see any number below here that I could use to break down, or use any number up here that I could break down the other down here? Another way to help us with that is you check and see if any of the numbers share a common timetable. So 2 and 4 are in the same timetable, and so too are 2 and 8. They are also in the same timetable, but you could only use it once. So I can't use the 2 to break down this and this. So 2 could go into 2 once, and I could break down either the 4 or the 8 with that 2. I'll choose the 2. I'll choose the 4. So 2 could go into 4 2 times. So you break down one at a time, top and bottom. Numerator into denominator, or vice versa. Now I know you guys are wondering, okay, I have 2 here and I have 8 here, and they share the same denominator. They share the same timetable, which is the 2 times table. But I cannot break down in the same house. I could only break down from one house to another house, or else we'll have chaos. So there's nothing else that we could break down. So what you're going to do is you're going to multiply numerator by numerator once there's nothing more you can break down. So that will be 3 times 1, which is 3, over 8 times 2. 8 2s are 16. And that's it. Let's look at another one. One more, division, and then we're going to look at the mixed operations, how they bring it to CXC. All right, so let's say they gave you 5/6 multiplied by 4/15. So you could start by encircling your numerators. I like to encircle them just to form that division in my mind. You don't have to do it. So I'm going to look below and see if there's any numbers that share a common timetable. Like if you see any numbers that you could find both of them in the same timetable. 5 and 15, they are both in the same 5 times table. So we could use 5 to break down the both of them. So 5 could go into 5 once, and 5 could go into 15 3 times. Then I see 4 and 6, they share a common timetable as well. They both share the 2 times table. So that means 2 could be used to break down both of them. Whatever timetable they share, you could use that number to break it down. So 2 could go into 4 2 times, and 2 could go into 6 3 times. I could only break down if there's anything in common in terms of factors from the numerator into the denominator, or vice versa. I cannot break down in the same house or else we'll have chaos. So I can't break down across like this. So once there's nothing else we could break down, we multiply numerator by numerator. So that's 2 times 1, which is 2, over denominator by denominator, which will be 3 3s, which will be 9. And that's it. When it comes to division, right? So when it comes to division of fractions, you want to remember KCF, not KFC, KCF. You're putting the chicken first. Now, if I was given a fraction like this, you're gonna head on to KCF. The K means to keep. So you're gonna keep the first fraction as is. The C means to change. You're gonna change your division sign to multiply. And the F means to flip. You're gonna flip the fraction after your division sign. So keeping this as is, change the sign to multiply, and flip the fraction after. And then you're doing the same thing as multiplying. And housing on numerators, you look below. Do you see any numbers that share a common timetable with those above? No. So we simply multiply numerator by numerator. 5 ones are 5 over your denominator by denominator. I cannot break down in the same house. Right, so that will be 4 2s, which will be 8. Now, when it comes to fractions, we have to blend all of these things. Right, so you got to blend all of those along with your knowledge on BODMAS. Right, so remember, BODMAS is telling you the order in which you are working operations. That's telling me work whatever is in brackets first. Of D division M multiplication, then addition, and then your subtraction. So it's going to be a blend of all of these. All right. So next, we're going to go to our past papers and let's see if it is that we can practice those that we were given. All right, so we're going to work them together. Now, what you guys can do is in your books as we do them, take a note of like which year we did. So like if you want to get in some practice, you wouldn't, I mean, you could repeat what we did in class, but you could get new practice as well. All right, so right now we're looking at the January 2020. All right, so let's look at the January 2020. So it says using a calculator or otherwise, calculate the exact value of the following. All working must be clearly shown. For this, I recommend you could use a calculator at the points that I told you guys if you're having trouble. But these, they range between 1 mark to even 3 to 4 marks. So let's say they gave us this. So you copy your question onto your answer booklet, right? So you have 4 1/5 times 1/3. Those of you who are comfortable with these, you could work ahead of me, okay? And you could always check your answer. So you copy your question, make sure that you copy the correct thing. Because if you copy the incorrect question and you take your time and you work it to perfection, you wouldn't get a full mark because, I mean, you'll get marks for your working, but you wouldn't get a full mark. So you just do a quick check to make sure that you copied it correctly. What I like to do first is if there's no brackets, I like to bracket what I am going to do first because the brackets show priority, right? Brackets basically is telling us that, hey, I'm going to work this first, right? So if there's no brackets, you put your brackets. And according to BODMAS, it's telling me if there's no brackets, I go on to division. If no division, I go on to multiplication. So I'm going to put brackets around what I'm going to do first. I then like to change all my mixed numbers into improper fractions. And remember, you simply multiply the whole number by the denominator before adding the numerator. So we're going to have 4 times 5, which is 20, and 20 plus 1, which is 21 over 5. Change all of them one time. 1 4 is 4, plus 1 is 5 over 4. Notice how I didn't leave anything in the previous step, right? I brought down everything, right? I made sure I brought down everything. The reason why is so that as you work through, you don't forget anything. Some people, they're going to work this down, and what happens is depending on the amount of things you have to do, we're humans, so we might forget, right? We're humans, and it's in our nature, right? You might forget, you might leave it out, you might rush through it and then be like, yeah, man, and I forget and things up on top. So what I like to do is to avoid that and make sure that I bring it all down. Even if I'm not working on it just yet, I'm just going to bring it down and leave it there until I'm ready for it. Meaning that I'll just keep bringing it down as is. Next, BODMAS tells me work what's in my brackets. So I have to multiply. I like to encircle my numerators, and then I look into my denominators. Do you see any number that shares a common timetable with any number up here? And the answer is yes. 3 and 21 could be found in the same timetable. So we're going to use 3 because they are both in the 3 timetable. I'm going to use that number to break down both of them. So 3 could go into 3 once, and 3 could go into 21 7 times. Nothing else could break down. So we then multiply numerator by numerator. and then denominator by denominator. So we'll have 7 ones are 7 all over 5 times 1 number. That 3 is no longer there. It has been cancelled and it's now replaced with 1. So it'll be 5 times 1, which is 5. Once you break down and you get only a single fraction in your brackets, you could release the brackets. Right, so I bring down this now. The -5, I just brought it down here, okay? So it's 7/5 from where I work the brackets, and then I brought this down. So I now have to subtract. In order to subtract fractions, my denominators must be the same. So I find the LCM of the two. If you have trouble finding the LCM, remember you could go through the other way. Whatever I do to the bottom to make it the LCM, my LCM of 5 and 4 is 20. So whatever I do to the bottom to make this 20, I must do it to the top. Same number I multiply by, I have to do top and bottom. Whatever I do to the bottom here to make this 20, 4 times 5 is 20. I must also do it to the top. So I'm going to work them out. 7 4s, remember you could use a calculator, right? I told you use a calculator. And remember you want to save on time. So you work them out. If you have to use a calculator, you use it. If not, you could do it manually. 7 4s are 28 over 20 minus 5 5s, that's 25 over 20. Now that my denominators are the same, I could just minus the numerators. So that will be 28 minus 25, which is 3 over 20. All right, so I'm pausing here. Tell me once I could continue by putting the letter F in the chat. All right, so let's take a look at this one. So in a case like this, they gave us 3 3/8 minus 2 1/4. Now this symbol, this line here, you have to remember that it also means to divide, okay? So what you want to do is you copy your question into your answer booklet. In this case, it's your notebook. Make sure that you copy it as is so that you don't make a mistake. Then my next step is I want to rewrite this in a like a linear form, like in a straight line, where I show that I understand that this means to divide. So what this is telling me is that I need to divide whatever is up here by whatever is down here. So what I'm going to do is I'm going to put this in brackets because I need to solve whatever is up here before I could divide it by whatever is down here. So I'm going to rewrite it. In this form. Then my next step is that I'm going to change all my mixed numbers into improper fractions, right? So changing, multiply my whole number by my denominator before we add the numerator. So we'll have 8 times 3, which is 24, and then 24 plus 3, which is 27. So it's going to be 27 over the same denominator. Keep it in brackets until we get a single bracket. Then we multiply, we change this into an improper fraction as well. So 4 2s are 8, 8 plus 1, that's 9 over 4. Then divided by 1, 2 is 2, and 1 is 3 over 2. So we work what's in the brackets first. But math is telling me, regardless, whatever is in the brackets, I have to do that first. Yes, they didn't give us brackets at first, but it's an understanding that we have to work out this first before we divide it by whatever is below here. So we find the LCM of 8 and 4. LCM of 8 and 4 will be 8. This is already 8, so I could multiply that by 1 to keep it as 8. Whatever I do to the bottom, I do it to the top. 4, in order to make 4 8, I must multiply it by 2. Whatever I do to the bottom, I must do it to the top. Right, so we're going to end up with 27 times 1, which is 27 over 8, minus 9 2s. 9 2s, that will be 18 over 8. Keep it in brackets until you get a single fraction in the bracket. Now notice, I'm not doing anything with this part yet, but I'm just bringing it down because I don't want to get excited when I reach the end and then I forget it, or we forget it. So we're going to have 27 minus 18. 27 minus 18, that's going to be 9. So I'm just continuing from here. And it's going to be 9 over 8 divided by 3 over 2. Right, so I'm just moving it up here so we could see it better. Same thing, I'm just rewriting. Then, when it is that we're dividing fractions, we have to head on down to KCF. You have to keep the first one as is, change your sign to multiply, and then flip the fraction after the division sign. So you're going to end up with 9 over 8 times 2 over 3. Remember, the flipping of fractions is also known as the reciprocal. And circle my numerators. Do you see any numbers belong that we have above or below that can be used to break down another? Or in other words, do you see any numbers that share a common timetable? I see 9 and 3, they share a common timetable. They are both in the 3 times table. So because they are both in the 3 times table, I could use 3 to break down the 2 of them. So 3 could go into 3 once, and 3 could go into 9 3 times. Then I see 2 and 8. No, I cannot break this down again, right? You could only break down once with it. Right, so that's it. Because remember, this 3 is no longer 3, it's now 1 because I broke it down. I see 2 and 8. 2 and 8, they share the same timetable. They are both in the 2 times table. So I could use 2 to break down each of them. So 2 could go into 2 once, and 2 could go into 8 4 times. Once there's nothing more we could use to break down, we just multiply the numerator by the numerator and then denominator by denominator. So I'll have 3 times 1, which is 3, over 4 times 1, which is 4. And that's my final answer. You show all of your work in order to get your full marks. And too, like if you make a mistake and you think you want to check over, it makes it easier for you to see. All right, so what I'll do is we'll pause there for tonight. And in our next session, I'm going to send you guys some to practice for homework. And in our next session, we're going to go through them, all the different forms.